Given an array of integers and a target number, return 3 integers in the array such that when added up, they equal the target. Hi everyone, we're here today for another Exponent mock interview with Andreas. For those of you who aren't already familiar with Exponent, Exponent helps you get your dream tech career with our online courses, expert coaching, peer-to-peer mock interviewing platform, and interview question database. Check it out at tryexponent.com. All right, thanks for being here with us today, Andreas. Would you quickly introduce yourself for our viewers?
Yeah, of course. Hey everyone, I'm Andreas. I am a software engineer at Modern Health and excited to do this coding interview today.
We're excited to have you here with us again. Okay, so our question today is, given an array of integers and a target number, return 3 integers in the array such that when added up, they equal the target.
Given that, I'd want to start out with asking a few clarifying questions. In this case, can we assume what is the size of the list we're going to be traversing?
You can assume that it's going to be medium size, maybe thousands of elements. Either way, the size should fit in a standard size integer.
What would the range of items be? Will there be negative numbers? Is there decimals?
Yeah, both positive and negative, but only integers, so no decimals.
Do we need to return one of the solutions or all of the solutions that could be possible for that target number?
For now, let's start with just returning one solution.
So can we use these elements more than once, or we can only use them each one time?
You can use each only once.
Okay, great. Great. Okay, so given that, I guess my most immediate thought is a brute force solution. So in pseudocode, I'd probably, so we have this list, we'll say 1, 2, 3. And my most immediate thought is that we'd want to traverse, and we have a target number. I guess our target could be 4. So we want to add up to 4. And given that, we could traverse this whole list. Actually, I'll just make it a little longer. 4, 5. And traverse this whole list, have a few loops, nested for loops. And these 3 nested loops, the initial loop we would go through each number 1, 2, 3, 4, 5. And at each of those, we would then check the numbers following. So at 1, we would check 2 in this secondary loop, and then on this third loop, we would check 3, and then add all those 3 up, compare them against each other, and if they match the target, return that result.
Okay. So then that's your brute force solution where you're checking every possible triple then?
Definitely, yeah. And so that would be, I guess because of these 4 loops, it would be n cubed time.
Where n is the size of the list, right?
Yes, exactly. And so that does not seem great. I guess space, we're not using any space, which is good. But we probably can get a little better of a solution there. So given that, this seems like a similar problem to the two-sum problem. And so let's break it down to maybe just computing given 2 numbers and then work our way up to the 3 numbers. So given that, a more I guess better solution we can probably come up with is an n log n time solution, or maybe n is what we're shooting for. Then, and because n squared would, I guess, match our n cubed one for the two-sum. For the brute force, we would just have 2 loops instead of 3, which is not much better. And so given that, we probably, so maybe we can start with an n log n. We could sort sort the array first. So now that in this case, I guess I provided an example that was already sorted, but let's mix it up. And so here, I mean, we know 1 and 3 is going to be a solution for the two-sum. And in this case, given that, we would sort the array. We'd have it as 1, 2, 3, 4, 5. So given this new array, we could check out both. Now that we know it's sorted, we can assume that the numbers, because of that, we can make the assumption where I think let's set up 2 pointers, one at the end and one at the beginning. So we have one here, I'll represent it like this. We have one here and then one here. And we'll want to check, compare them with each other. And so we can add them, iterating through that. So we have a for loop here where we start at the end and we also have one at the beginning. And going through it, or actually, I believe this might be a while loop. So going through it, we would check, okay, 1 plus 5, that's 6, continue on. 2 plus 5, or 1 plus 5, so we want to go smaller, so we move the top one down. And since 1 plus 4 is again too big, it's at 5, we want to move it down one more, decrement the top one. And now we have our solution, 1 plus 3, which is 4, which we could then return. The, I guess, pseudocode of this, we'd have this while loop that would check while the low is less than high, then we could do an if where low plus high, if it's equal to, or actually let's define here, low, the target, rather sum, is equal to low plus high. And so low plus high, if our sum currently is equal to our target, then we'll return. If our sum is less than the target, then we'll want to increment our low. And then finally, if the sum is, or otherwise, we'll say, here, I'll scroll down here. Otherwise, we'll decrement high when the sum is greater than the target. And so given that now, so we have kind of this formula for going through that gives us n log n time. I think.
Okay. And sorry, just to recap, so this is n log n time for when you've reduced the problem down to 2 sum, right? You're only finding 2 integers that add up to the target?
Yes.
Mm-hmm. Okay.
And so we have this solution. Alternatively, in this case, since another way we could handle it with 2 is, I guess to simplify it, we would put all of these numbers in the array into a hash table. So numbers to a hash table, and the hash table would be composed of each of the numbers, and then if their occurrences in the array. And so given that, we could have a constant like O of 1 time lookup, and we could tell or rather the index would be at each of those. And we could say the index, if the index of a given number is at, if that number already exists or we've seen it as we go through each of the numbers, then we know that a pair exists and we could return that value. That gives us O of n time, which is great, but also space-wise, it's O of n space because we have to put all of these numbers, or in the worst case, we put all of the numbers into the hash table. So yes, we have O of n, and then O of n space and O of n time. So that's great for two sum. We should talk about three sum, I guess. And so for three sum, essentially we're adding on that additional number, but that we're trying to compare against. So we're now summing three numbers. However, we can reduce it where essentially we can iterate through the outer loop. So we have these three loops here. We can take away these two loops, run twosum, which we just came up with down here, and iterate in the outer loop and run twosum on on the rest of the array after we iterate on the external loop. Does that sound good to you?
Yeah, that sounds good.
Okay, awesome. So, however, now that I'm thinking about it, like one consideration is, so it seems like, okay, it makes sense. Let's run, let's use the better time, the O of n time and O of n space solution for the two-sum problem that we did for a three-sum. However, I think because we now have this outer loop, we're going to, at best with that, we're going to have, let me think, because we're sorting n squared, we'll have to go through each of those. Let me think. Is that correct? Yeah. N squared time could be our best in this case.
Because for each of the possible targets, it takes linear time, right?
Yes,
exactly. And there's n targets, and then each of them take n time, so n squared, right?
Yes, exactly. So given that, actually our limiting factor is that. So now the n time, we can't just have n time anymore, so it's not really trade-off of time and space. It's just going to always be n squared. So since we know that, I think it makes sense for us to go the route of the first implementation we had right here of twosum, because now we don't have, because n log n is less time than our n squared time, so it doesn't matter if we're spending more time sorting, because we'll have less space, constant space, which is awesome. Cool. Okay, great. So given that, I guess we can go ahead and start coding that.
Yeah, that sounds great.
Great. And so, okay, I'll define it here. Maybe we can define a function. Let's see. Oh, how did we want? Is it fine if we just return the values in an array? That'll be fine.
That sounds good. Mm-hmm.
And oh yeah, I guess actually one last question. Can we just return null? Or or one more clarifying question. Can we like return null on if we don't find a match to the target?
That sounds good. Hmm. And so right now you're programming the two sum solution, so it's only returning 2 elements. Are you going to change the output later to return 3 instead?
Yes. Oh, yes, that's a great point. So I'll add in that extra loop, and then I'll add that variable into this array. Thanks for calling that out.
Okay, sounds good.
And oh yeah, an additional question: do we need can we assume the input will be like what we expect? Like there won't be, I guess, arrays of length less than 3 or anything, or should we sanitize for any of that?
Sorry, are you saying sanitize for invalid inputs?
Yeah.
Yeah, don't worry. You can assume that the inputs are all valid integers.
Okay, great. And so, given that, cool. And so we have that syntax, and then, okay, so given this, we'll say we're going to iterate through the whole length of the array, I plus plus, I minus minus. Okay, oh yeah, we have to define low and high, and so low is going to be the value. Oh yeah, so here we have this first counter will be here, we'll call it counter 1, and then low will be here, and then high will be here. And so we'll iterate through each of those, and then on the remaining values in the array, we can assume that those are the low and high. Actually, let's make this a working solution. Well, I guess we can test this one for now with the target in the list to see if it returns null. So, oops, uncaught syntax error. Unexpected identifier. List. Okay. I see this. Uh-oh. Where is my bug?
Is it on line 34, maybe?
34, sum is equal to, oh yes, great catch, thank you. Okay, so run that. Okay, great, null, awesome.
Okay, perfect.
And so let's do a working case. And so 1 plus 3 plus 5, let's say. So let's do run that. 1 plus 2 plus 6. Oh yeah, 1 plus 2 plus 6. That works.
Yeah, that's right. Great.
Awesome. Okay, great. Shall we try a few more inputs, or are we satisfied with this?
Be good. Yeah.
Cool. Let's
maybe something different from the cases that you've already tried.
Yeah, sounds great. So we'll do maybe. Oh, so one of our clarifying things is we needed to account for the using each element only once. So if we have let's do I don't know, 3 3, or maybe 1 2 3. We don't accidentally use 2 twice and then get, I don't know, get 4. Oops, list has already, list 2, type 2, type 2. And that's null. Okay, and then maybe something like this. So can it handle cases where there's multiple? And we'll say 6. Target 2. Null. Interesting. Oh yeah, because we're adding 3. Whoops. Yeah. So okay, great. That works too.
Okay, so I think we haven't tried any examples that have negative numbers in the input yet.
Yes, great point. And so we need some negatives. So let's say 6 plus negative 3 should be 3. Nice. So that one seems to work.
Okay, perfect.
Cool.
All right, I think that's a great place to pause. So congrats, you did a fantastic job.
Thanks.
I'd love to hear from you. What did you think of this interview? What do you think went well? And what do you think you would change if you were to go back?
Yeah, I think like I tried to make sure I laid out like any assumptions or thinking about any clarifying questions before, jumping into code or like starting to write things. I think that's like the top priority. And then after that, I tried to lay out the pseudocode. I hope the pseudocode was clear, and like how all of that worked. I was speaking a lot, but I know besides that one solution of pseudocode I ended up using in my threesome that I could have used, like I didn't outline the other ones with as much pseudocode. So I hope it was still clear that I understood those, even though I didn't outline them as much.
Okay.
Yeah.
Anything else?
No, I think that's pretty much it. Yeah.
Okay, great. Well, okay, so I really like that you broke down the problem first initially by reducing it to a simpler form of the problem. So you went from adding up 3 numbers to hit the target to first considering the case where you only need 2 numbers. And then it was like a very clean and elegant reduction of the 3-sum to the 2-sum problem. So that part I really liked. I also like that when you were working on the 2-sum problem, you came up with that 2-pointer solution, which was both really efficient in terms of time and space. And it was and sorting the input first as pre-processing was also very clever for reducing the time even more. Yeah, lastly, I also really like that you illustrated a logic on the as you were coding on concrete examples that made it really clear what the algorithm was supposed to do. And you also asked about like a lot of important edge cases, like whether or not you might have invalid input or if there's no answer to the particular input. So the one thing that like I think maybe could have been done even better, and I think you sort of hit on this point, was like in terms of structuring your code. So because the solution was a reduction to the 2-sum solution, I think the code for the 2-sum solution could have actually been factored out into a separate function. It's always important to make code as modular as possible. It makes it much more readable, and then it's easier to test as well.
Totally. Yeah, that's a great point. Yeah, I did think about that for a second, and I like forgot about it. So great point.
Great. Okay. Yeah, but you did a really great job. So thank you so much for joining us today, Andrea.
Awesome. Thank you, Angie.
Yeah. Okay. Thanks everyone for watching, and good luck on your upcoming interviews. Bye, everyone.
Thanks so much for watching. Don't forget to hit the like and subscribe buttons below to let us know that this video was valuable for you. And of course, check out hundreds more videos just like this at tryexponent.com. Thanks for watching, and good luck on your upcoming interview.